Hello, I'm Seba, one of the many caretakers of the Maya forests, and today we'll talk about the Yucatan Peninsula. The Yucatan Peninsula is a 145,000 kilometer square limestone plain bordered by the Gulf of Mexico and the Caribbean Sea. The region's climate is predominantly warm and subhumid, although some coastal areas are drier, while others, such as parts of Campeche and Cozumel, are more humid. The Yucatan Peninsula has two main seasons, the dry season from November to May and the rainy season from June to October, with warm temperatures year-round ranging from 25 degrees Celsius to 30 degrees Celsius, 77 degrees Fahrenheit to 86 degrees Fahrenheit, and often exceeding 40 degrees Celsius, 104 degrees Fahrenheit, from April to June. Annual rainfall surpasses 1,500 millimeters. The midsummer drought, known as canicula, July to August, is a short dry period within the rainy season that favors the cultivation of avocado and squash. This region is also vulnerable to tropical cyclones, low-pressure systems with strong winds and heavy rainfall that occur mainly from June to November. These phenomena are classified as tropical depressions, winds up to 63 kilometers an hour, or 39 miles per hour. Tropical storms, 63 to 118 kilometers an hour, or 39 to 73 miles per hour, and hurricanes, winds exceeding 118 kilometers an hour, or 73 miles per hour. On average, the peninsula is affected annually by one cyclone from the Atlantic or Caribbean, making them the primary meteorological and economic threat to the region. The nortes, from November to February, are cold fronts, masses of cold air from North America that collide with the warm tropical air, causing a rapid temperature drop. Winds of up to 50 kilometers per hour, 31 miles per hour, and sometimes rain. In the peninsula, these nortes can cause flooding and affect key sectors. Droughts and delayed rainfall impact honey production, crops, and livestock, and increase the risk of wildfires. Heat waves in the peninsula, which occur between May and June, are caused by high-pressure systems that block cold fronts and humidity, intensifying the heat. Global warming, deforestation, urbanization, and the El Niño phenomenon can make them worse. Maya communities have adapted their architecture to the climate by using local materials, such as limestone, palm, and wood, to maximize ventilation and regulate temperature. Palm roofs are lightweight, resistant to moderate winds, and provide thermal insulation. Hammocks are another adaptation to heat and humidity. Their suspension allows better air circulation and prevents contact with the hot or damp ground, maintaining a cooler temperature. However, in winter, air humidity can condense on the hammock if the ground is not insulated, reducing thermal comfort. In general, the Maya adapted their habits to their environment. For example, there are almost no Maya ruins on flood-prone coasts. One exception is the coastal archaeological site of Tulum, built on a cliff and protected from cyclones by the coral reef in front of it. The milpa, the foundation of Maya agriculture, is adapted to the climate through crop diversification and agroforestry to mitigate drought and ensure food security. Soil conservation practices, such as using plant cover like squash leaves, help retain moisture and prevent erosion. The Maya also used ancient cisterns called choltuns to collect and store rainwater, which was essential during droughts. Their agricultural and social calendar was aligned with climatic cycles, and they held rituals to honor the gods of rain and fertility, protecting the ecosystems of the Yucatan Peninsula, reforesting to regulate temperature, respecting coastal dunes, and avoiding construction in flood-prone areas are key to thriving in this climate. Practices such as milpa agriculture and rainwater harvesting are examples of technologies that have worked very well in this environment and can be combined with modern techniques. Recognizing the region's rich cultural heritage, promoting environmental education, and improving urban planning regulations are essential for a sustainable future.